The swoosh. I like that.
How's it even possible? I don't know.
How'd you go? Oh, I did.
Wait, what's this? Genetics?
No, it's, DNA versus RNA.
Oh.
I think she's at 1.7. Wait, are you going to get it? Because I didn't know there's how many questions I have. I heard yours had 50 something. I had 20.
Healthy.
I got 61. Nice. Well, I feel like, I mean, after the class, I was like, I know I didn't do well. And she was like, why haven't I kept your grade in? And she was like, "Grade, tell me." And I was like, yeah, no, I didn't. So hard. Go. I mean, that's the first one. I feel like more. I've got I don't remember when Korean drugs like 6 mass. Oh my gosh. Holy. It was hard. Like, it was like, I didn't even see else. She didn't even like, he looked at, it was annoying. So it made me like, the questions really, and like, multiple, barely. She said, there was one girl that stayed in my last class, and she stayed for like 30 minutes. I honestly, there was times where some people it's just too bad. One person gets cancer. Medical reasons. She's always. I don't think just get to have some stuff or something like this.
It's either a mistake or
She's always. Yeah, I swim. Well, so that's some, most, I have, I'm biased, because they're, most of my friends like really sad, do you know the show? Yeah.
They're not just
They're
trying to
not,
zoom
there's a couple of people,
No, I'm just
but
looking.
I don't talk to them about, I just don't know. Did they used to? Did they used to go? Like, really bad. Oh, no. We swim. Oh, okay. Oh. Everybody thinks. Yeah. So if my stepsister wrote to my mom, like, Mom, I don't want to better for the babies, it's like small as a five. And she's like, I don't want it, so I want, I need to smell better five. My mom, what's your phone? She goes over one, stops on her
I'm just
in like high heels. It's like, I don't know. Like, the phone was shattered. And then her mom bought her my phone. Yeah, that's what I had.
All right, guys, if you haven't got your packet out yet, please do that. That's where we're starting. Get out your homework packet, the packet from yesterday with your homework in it.
She's not.
Okay. Checking the packet, checking the homework from yesterday's packet is where we are starting. And I just realized I didn't check that one for.
What exactly was wrong? So I did something, I don't know how to do
I did post recordings. You could check again. It was the packet up to the end of the page we were on.
Okay, yeah.
So this is the first thing that I think we did not do in class yesterday that's in the packet. So this was on page 2. If you haven't numbered, that's also something you might want to do. So folks in the digital world, we are checking homework first. So from the packet from yesterday, you were supposed to finish anything up to the bottom of the page we were on. And this was the first thing that we did not do together, I think. So there's that.
Why is it not assigned, cosine, tangent for Steve? Is it not-
Well, because what would the opposite? Well, the opposite would be the hypotenuse. So what would the adjacent be? It's just always with respect to the acute angles. We always do sine, cosine, and tangent from respect to the acute angles. When we talk about the opposite and the hypotenuse and the adjacent, that's always with respect to one of those. Okay, so next on the next page, I think we finished all of the next page, maybe. No, that was the one we didn't do any of, I think. Yeah. There we go. So here are the ones at the top.
Miss Backfish, you aren't screen sharing.
Thank you so much. Okay, and checking the next set down. Okay, the bottom of this page we already went over together, but we need to go ahead and talk about 7 and 8. One of the first things I want to talk to you about with 7 and 8 is just sort of a convention that is followed in math classes from pretty much Algebra 2 on up. It says in ABC, C is the right angle. Number 7, below the ones we were just checking. In triangle ABC, C is the right angle. A, little a, lowercase a is 40, lowercase b is 30. Here's what you need to know about that. The convention I'm referring to is when you have capital letter names for points, which is always the case, in this case, the vertices of my triangle, the lower letter case, the lower of the same, the lowercase of the same letter is usually used for the opposite side from that. Because remember, sides and angles go together. In other words, if you have an angle of a certain size, okay, that angle is bigger, my hands are now farther apart. So the side across from it's farther longer. If my angle is smaller, my hands are closer together. The side between my hands is smaller. Smaller angles are across from smaller sides. Bigger angles are across from bigger sides. Okay, so that would be A. This would be B. This would be C. Okay, so that was one of the things you needed to know for 7 and even more importantly for 8. So A is 40, B is 30, and 3, 4, and 5 is the Pythagorean triple. And remember how I told you any Pythagorean triple, you can get another one by multiplying them all by the same number? 3 times 10, 4 times 10, 5 times 10. You didn't have to know that or think of that. You could use the Pythagorean theorem to find that. Okay, so it says find the exact values of tangent of A and cosine of B. Tan of A, here is A. The opposite from A is this. The adjacent for A is this. So tan of A is going to be opposite over adjacent because that's the definition of tangent. So it's going to be 40 over 30, which is 4/3. They did tell me to find the exact value. That means don't do a decimal. Leave it as a simplified fraction or a simplified radical. Okay, the next thing we were asked to find was cosine of B. Here's B. From B, this is the adjacent side. This is the hypotenuse. Adjacent over hypotenuse is cosine. So cosine of B is going to be 40 over 50, which again I can reduce, and that's 4/5. So there are my answers for number 7. Questions about that? Okay, number 8 says in PQR, R is the right angle. Okay, and then P, lowercase p, which would be across from the uppercase P, it's right here, is 5. Lowercase r, which would be across from the uppercase R, is 13. That's a Pythagorean triple. 5, what, and 13? No. Don't just guess. And this time y'all could have found it out by doing the Pythagorean theorem. 13 squared is 169 minus 5 squared, which is 25. 169 minus 25 is 144. 12. Yeah. Okay. So find the exact values of cosine of P. Okay. Cosine of this angle means the adjacent to that angle over the hypotenuse. So cosine of P is going to be 12, which is the adjacent, over 13, which is the hypotenuse. And that can't be reduced, so that's my answer. And then the next thing I'm asked for is the tangent of Q. Tangent of Q from Q, that's opposite, which is 12, over adjacent, which is 5. So tan of Q is opposite 12 over adjacent 5, so 12/5, and that's it. Okay. Any questions on this page? All right, turning the page, and this is page, what is that? 4. Page 4 is where we start finding missing side lengths. Let me just tell you right now, this is my mistake. I meant to tell you number 7 there is basically on the wrong page. Number 7 is not in line with everything else that's on this page. Don't mark through it. We're going to just hold off on talking about number 7 until we're talking about finding missing angles, because that's what you're doing in number 7. So if you tried number 7, great. Hold off on that. Question? Maybe. I haven't done it yet, but we'll see if we have time. But we're going to talk about missing angles Monday anyway, so we'll talk about them then. All right, let's go ahead and work through these examples that you guys see at the top, but have not seen anybody work, and it might be a little bit more helpful to see it done as opposed to already done. All right, so this is what we got. Okay, so first thing I need to do is figure out, in terms of that particular angle, what sides I'm working with. Okay, this is the hypotenuse, so that's the adjacent, and this is the opposite. All right, so then I look at my definitions. Let me just go ahead and write those out here. Sine of an angle is the opposite over the hypotenuse. Cosine of an angle is the adjacent over hypotenuse. And tan of an angle is opposite over adjacent. And I'm going to ask you guys to humor me here, because what I wish to do, no, I can't do it. Never mind. Okay. So I'm looking for the one that involves the opposite and the adjacent, and that's the tangent. So I'll say tangent of 27 degrees equals opposite over adjacent. These are not just the definitions of my basic trig functions. They're also equations, and so they give me the guidance. They're my models for how do I set up the equation. Anytime I am looking for a missing side or a missing angle, I will set up an equation using one of these as my model. And I set up the equation the exact same way every time, no matter which side is missing, no matter which angle is missing. Okay? So next thing I'm going to do is I can multiply both sides by 15 to get it out of the denominator. But another way of thinking of that I just want you to be aware of is it's like I'm cross multiplying. It's like that's over 1 and I'm cross multiplying. So 15 times tan 27 equals x times 1. At this point, you got to ask yourself if x is alone, if your variable is alone. If it's not, you don't stop here. Notice I haven't picked up the calculator yet. Okay? So you just keep solving that equation, doing what you need to do to both sides to get the x or the whatever alone until it's alone before you touch the calculator. This time it is alone, so now it's time to touch the calculator. And what's on the opposite side tells me what to type in. In other words, if this is what x is, that's what I type in. So 15 times tan 27 will give me my answer. Remember that if you are using a graphing calculator, you need to make sure it's in the right mode. I'm going to go with hundredths. Okay? You need to make sure it's in the right mode, because it can be, a lot of graphing calculators default to what's called radians instead of degrees, a different way to measure angles. We're in degrees because we were given angles in degrees, so we need to stick with degrees. Notice here, they got a different hundredths place round than me. That's because they did what I keep telling you guys try not to do. They rounded earlier in the problem. They went ahead and said tan 27 and they rounded there. And so then they're going to be a little bit less accurate because the earlier you round, the less accurate you are. If you want your most accurate answer, wait till the end to round. It's also just simpler to do it that way with these. Okay, wait until your variable is by itself before you pick up the calculator. All right, the next one, number 4. We have 18 here, 40, and y. So first thing I need to do is figure out which side is which. This is the hypotenuse. This is the adjacent side. And then I need to figure out which trig function to use if I'm working with the adjacent and the hypotenuse, and that would be cosine. So I'll say the cosine of my angle equals adjacent over hypotenuse. Now let me just, quick side note here. Cosine of my angle. Anytime, that's what triggered me wanting to talk about this. Anytime you're doing sine, cosine, or tangent, you will never have it by itself. You'll never have just sine, or just cosine, or just tangent. It's always of an angle. You may not know the angle, so you might have an x there, or a theta, or the capital letter of that angle, vertex, or maybe you do know the angle. But you're never going to have just sine, okay? It's always sine of something, cosine of something. Because if you don't know of what angle you're talking about, then the opposite and the adjacent, the context, there is none. Okay, we need to know what perspective we're looking at this right triangle from. All right, so I'm going to cross multiply and I get 18, times cosine 40 equals y times 1. Is y by itself? Yes, and that's what tells me it's time to pick up the calculator. If y was not by itself, I would not pick up the calculator. And y is about 13.79. Okay. Questions there? Okay, so we got 3 problems left on this page to work because I told you we did 5 and 6 yesterday in class. I told you we're going to skip 7 for now. So let's go ahead and look at number 8. Okay. Which trig function do I need to use to do this one? Tangent, okay? Because this is the opposite side and this is the adjacent side. So I'm going to write an equation with the tangent function. So tan of the angle equals opposite over adjacent. And most of these are convenient in that my variable is in the numerator. And when that's the case, once I've cross multiplied, it's already alone. And then I'm ready to pick up the calculator. It's when the variable's in the denominator that after you cross multiply, you'd still have more to do. Okay, so here we get 22.55. Number 9. Okay, we've got 29 degrees here, 29 and x. Eric, what'd you get for this one? I don't know that. I figured since you're sitting there on your phone, that must mean you've actually done this already and you thought it was too easy to pay attention to. Could you hear that I was talking? Put your phone away. Okay, so we have the adjacent and we have the hypotenuse. And that makes it the what? Cosine. So cosine 29 equals x over 29. Then I'm going to cross multiply. And that's when I know what to put in my calculator. So Emma, what'd you get on this one?
I got 25.36.
That's exactly right. There you go. Okay, next question, number 10. Matthew, what'd you get for this one?
That one I couldn't figure out because
Okay.
yeah.
All right, that's fine. Morgan, what'd you get for this one? Okay, Sage. You there? Okay, hang on. I'm looking for a quick answer. How about Sonia, what'd you get? Sophia, what'd you get? 24.15 is correct. Yes. Here is my adjacent side. Here is my hypotenuse. So it is also going to be cosine. When I cross multiply, I get 32 times cosine 41. And that gives me x. And that tells me what to put in the calculator. And that's 24.15 as Sophia got. All right, questions on anything on that page? Okay, on the next page, I want you to flip over to the next page and do number 4. Everybody do number 4 on the next page. I'll go ahead and draw it if it makes it more convenient for you.
What page number is it?
I think it's 5. It looks like this. Yeah, it's on page 5. Sure. Just not right yet. Hold off. Give everybody a little bit longer here. Okay, Sage, what'd you get? 8.28. Anybody else agreeing? I haven't done it yet. Let me just go ahead and check. That's not what I'm getting. Somebody else want to volunteer? Caroline, what'd you get? No. 8.28. Sophia? Nope. Now keep in mind, y'all, you're looking for the hypotenuse. It has to be longer than the legs. Go ahead, Eric. 11.12 is it? Yes. Let's go ahead and do this one. Okay. This is the first one we've done where when you set it up, your x is in the denominator. But I've been telling you how to do this. So let's see. This is your opposite. This is your hypotenuse. That's a good reason. Yeah, that's one of the main ways to mess one of these up is to choose the wrong trig function. Okay. So because it's opposite and hypotenuse, I'm going to use the sine. So sine of 46 degrees equals 8 over x. So now I'm going to, sorry, my 8 is so tiny. Well, 8 needs some growth hormones. I don't know. Okay, so when I cross multiply, I get x times sine of 46. And on the other side, I get 8 times 1. So your x is not alone. If your x is not alone, you're not ready to go to the calculator. Okay, I got to get x alone. If x is being multiplied by something, then I'm going to divide by it to get it by itself. Okay, and so divide both sides by sine of 46 degrees. And now x is alone. So now this is how I get my answer. Okay, if you're sometimes I have students ask me, how do you know whether you're going to multiply or divide? Solving the equation is how you know. That's the whole idea of wait until x is alone on one side. Go through the process of getting your variable alone, and whatever's on the opposite side tells that. Okay, so we haven't really talked about the mnemonic devices to remember them. I wouldn't expect you guys to necessarily need them because you can have your open notes, so you can have them right in front of you. Okay, but somebody in the chat was just talking about it. Those in the room who didn't see that. So let's go ahead and talk about that. There's a mnemonic device that is very commonly used to remember which trig function goes with which ratio. Okay, and it's SOHCAHTOA. Okay, we could also write it like this. SOHCAHTOA. And the S stands for sine, opposite hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Some people take it one step further, and I've heard quite a few sentences used to help remember this. But again, this year, you guys don't have to remember it. You can have it right in front of you. Usually you do, though. And in future years, you'll probably have to remember it in other classes. Okay? But I've heard lots of people come up with sentences. There are several common ones. Some old horse caught another horse taking old apples. Some old hippie came a hopping, tripping on acid is one I heard many years ago to be very, very commonly used, actually. But I don't usually get into any of that just because that's a mnemonic device to remember a mnemonic device. So you're like getting further removed from just the basics. And I think SOHCAHTOA is easy enough to remember for most people. But again, you guys don't really have to memorize them. So you could just look at it. But there they are, if that helps. You should have them written down. So it shouldn't be easy to forget them with open notes. All right, what I want you guys to try right now is I want you guys to go ahead and do numbers 1, 3, and 6 on this same page. 1, 3, and 6 on this same page.
set this up. Using my calculator to find out.
Was it-
Any way I can-
What are you looking for?
Can you set that up for me? Because like whenever I click something,
I don't know.
that's the only thing.
I have no idea. I'm not good with Casios. Let's see. No, that might have done it. Is that what you mean? Like trying to get you back to a home screen? Okay, let me just point out, these say round to the nearest tenth. We've been rounding to the nearest hundredth. So either one, I guess, is fine. I rounded to the hundredths. But I wanted to point out in doing that, Some of you are kind of struggling to round number 1 to the nearest hundredth. Had them written down. I was hoping to reuse a sheet I already wrote on. I only do the same problems 17 times a day. There we go. If you round number 1 to the nearest hundredth, you should have this. Okay. If I do 10 times 10 to the 27, 10 of 27, excuse me. This is what I get. The hundredths place is the one where the 9 is. The 5 right after it says that's going to have to go up. When you go up from 9, you go to 10. That's the next number up. So this is like your 10. Yes, sir.
I thought you told us to never look at the number after.
I did, but we're looking at the 9. We're looking at this is if you're rounding to the nearest hundredth. If you're rounding, that's what I'm talking about right now, is rounding to the nearest hundredth. If we're rounding to the nearest hundredth, then we look at this number. Don't look at the one after that. Okay. All right. There's your work for 1. There's your work for 3. And here's your work for number 6. So you should have gotten 5.1, 5.44, and 6.76. Questions on any of those? Yes, ma'am. Number 6. Let's go ahead and do it. Hang on one second. Alrighty. Slightly distracted. Sorry about that. We have our 2 legs are X and 7, and this is 46. Okay, so this is the adjacent side, this is the hypotenuse, and this is the opposite. So I'm dealing with opposite and adjacent. Opposite and adjacent is tangent. Okay, so I'm going to do tan 46 degrees equals opposite over adjacent. And then I'm going to cross multiply. And that's what I get when I do that. X is still not alone, which is what tells me I need to divide by tan 46 on both sides. Now X is alone, so that's what needs to go in my calculator. 7 divided by tan 46 is how I get 6.76. If you followed the directions instead of, instead of going with the hundredths because we had been, here you'd get 6.8. Number 1, you'd get 5.1. And let me double check. You definitely, did you go back and calculate it? Yeah, you definitely do. Get 5.4 on that one. Okay, on number 3. Questions there? Okay, anybody want to work any of those? We're fine to do that. Okay, on the next page, flip one more page. I want you to do 7 and 11. This is on page 6. On page 6, 7 and 11. Yeah, let's go ahead the 100th. 100th would be good.
I don't think your stuff is a good question, because I'm worried you'll get back.
If you're already done with those, go ahead and try number 3 as well on that same page. You guys ready to check 7 and 11? Okay, how about if I ask Cole, what'd you get on 7? 24.36 is perfect for number 7. Good. Number 7 is 24.36. What about on number 11? Alex D, what'd you get? I got something very, very, very close. I got 141.82. So you're definitely right. I don't know why we rounded this a little bit differently. But on number 11, I got 141.82. Let me point something out to you here. Is we've talked about how the hypotenuse has to be the longest leg or longest side, excuse me, not leg. So we know that if we get a number for a leg that's bigger than the hypotenuse, we did something wrong. So we can use that to sort of help us have some perspective. That's also true in problems like number 11. Okay. We already talked about this a little bit. Since this is 15 degrees, this angle, these two angles, remember, in every right triangle have to add up to be 90. Okay, so this will be 75 degrees. 75 degrees is much bigger than 15 degrees. So if 15 degrees goes with a side that has a length of 38, I can expect this side to have a much bigger than 38 length. Because 75 is much bigger than 15. Okay, so that can also help me just to get some, like for instance, in number 11, that's a much bigger number than we've been getting. So I had the same experience. I got 141.82 and I was like, what did I type in wrong? And then I look and I'm like, oh, well, if the other leg is 38 and it's across from that little bitty angle, then yeah, it makes sense for this to be a really big side. Okay. Do we need to do either one? Let me just show you my work on those two. And if you need to see it done with the work, that's still fine. So here's my work on 7 and 11. Tell me if we need to talk about one of those. What'd you get on 3? I agree, 15.09. You got it. Okay, so your homework is a separate worksheet that I have linked to today's classwork on Google. It's basically got I think it's got 10 problems like this, and then in the bottom it's got a few problems where you're using this to be able to find enough information to get the area of a triangle. And I reminded you the area of a triangle formula is 1/2 base times height, but I put that in the description. So go check out your classwork on Google Classwork and have an awesome weekend. It looks like it's going to be beautiful. And I said this on your classwork too. Get outside. Go outside and enjoy it.